Hey, cool cat mathematicians, my fifth graders, multiplying decimals using the standard algorithm and models. I'm going to show you just the standard algorithm right now. Sorry, I was tripping over my trash can. And then when we look into the lesson, I'll go into more detail of how we use models, aka those hundreds blocks or those graphing paper with 100 different squares on them to represent one whole in the decimals and to multiply those groups. That'll make a little bit more sense when you see the visual learning. So the first step we have is to drop the decimal. So I'm going to give you a simple multiplication problem. This is number 8 in your book. 5 times 5 tenths. So how do I do 5 times 5 tenths? So first thing you want to do is drop that decimal. You're rewriting that problem with no decimals. So it's 5 times 5. There is that zero placeholder in there. You can drop that if you like. You can write it in there if you need that to be comfortable with this process. We know 5 times 5 is then 25. So step 2, we multiply. See here on this one I had 4 and 34 hundredths times 5 became 434 times 5. So 5 times 5 is 25. Which leads me to the next step. Interpret the decimal and move the decimal point left. How many, and you're moving it to the left, how many decimals numbers you have, or decimal pieces. I like to just say decimal numbers that you have in the original two factors, not just one factor, two factors. So when I go back up and look at my factors of 5 and 5 tenths, only one of them is a decimal, and there's only one decimal number there. Everything to the right of the decimal point. Everything to that right of the decimal point would be my decimal numbers. If that number originally was 513 thousandths, we would be asking ourselves how many, and that would be those three decimal places, but it is not that number. So looking at 25 or 25, we are starting here at the break between the ones place and the tenths place. So here's my ones, and then to the right of that decimal is my tenths. So I have my ones place, and then this imaginary number here, which is 0 right now, is in my tenths place. If you have to draw a 0 in there, you could even do that. I just suggest leaving it be. So we have 25. We need to move it one decimal place to the left. So I'm going to take my decimal, and I'm going to loop it once to the left. This is my new decimals location. I just moved it over there. So it's just really here. Again, start at my ones place to the right of my ones place, that break between whole numbers and decimals, and you move it to the left as many decimal numbers you have in your original factors. So in this one, I only have one, so I'm just going to move it one. So if I rewrite my new number, it's 2 and 5 tenths. Let's try this process with a more complicated problem because that's how math works. Let's look at 2 and 4 hundredths times 2. So I have 2 and 4 hundredths times 2. First step, drop the decimal. So I'm rewriting that as 204 times 2. Step 1, done. Step 2, multiply. You can use any algorithm you want. I like partial products. You know that about me. 2 times 4, 2 times 0 tens. We're just going to leave that as 2 times 0 tens. 2 times 2 hundreds, which would be 200. 100, 200. So we have 2 times 4, 2 times 0, 2 times 200. 2 times 4 is 8. 0, 2 times 200. 2 times 2 is 4. Add my zeros is 400. So I have 408 as my uninterpreted product. Do you like that? So step 3 is to interpret that decimal and move that decimal point to the left. How many how many decimal pieces you have. Move that light a little bit so you can see better. This document camera is a little finicky. If I look at 2 and 400ths, I have 1, 2 decimal pieces there, and in 2 I have no decimal pieces because you can assume there's a decimal point here and nothing to the right. It's just 2, not 2 in any little piece of a number. So we have those 2 decimal points. We're going to move our decimal point to the left 2 spots. So start at the ones place and move it 2 spots. 1, 2. My new number becomes 4.00, or just plain old 4. When you have no decimal numbers there, they're just those 0 placeholders, you can leave it and I'll count it correct, or you can drop it and I'll count it correct. Either way, 4.00 is the same as 4. 4.0000000000 is still the same as 4. One last time for the benefit of the group. Let's try this now with, in your book, I don't see any that have 2 decimals, so I'll just continue with problems from your book. The process doesn't change with 2 decimals, so let's try 55 hundredths times 3. So I have 55 hundredths, which is 0.55 times 3. Well, looking at this, you might be confused when you do step 1, drop the decimal, because you're saying to yourself, oh, so I have a number that's 0.55 times 3. There's nothing in that hundreds place. Well, when there's nothing in that hundreds place, you can ax it. You can get rid of it because it's just going to cause you to multiply by 0. And I think that confused a little of you when I showed this method to you as a preview. So let's look at our partial products now. 3 times 5 is 15. 3 times 50, 50, 100, 150. That looks like it's going to be 5, 6, 1, 165. So when I think about step 3, interpreting the decimal, moving the decimal point to the left, how many? So I have 165 as the number that's being interpreted. Here's my decimal point there. I have 1, 2 decimals, numbers there, no decimals on this side. I'm moving to the left 2 spots. 1, 2. My new and actual product is 1.65, or 1 and 65 hundredths. To check your work, you can use the strategies that we practiced last week. And what they include would be to round these numbers and multiply. So looking like I would multiply or round this to the nearest whole number. That 5 would tell me to give it a shove because we're trying to drop all the decimals to a 1. We have 1 times 3. 1 times 3 is 3. Pretty close to 1 and 65 hundredths. Not real close, but if you think of 0.5, it's really a half of 1. And half of 3 is 1.5, which is insanely close to 1.65. It's only 5 hundredths off of that number. In your lesson today, you will find that they are going to model these with those grids. I'm not sure if you still have the graph paper I gave you all at the beginning of the year. If you do, that might be helpful. If not, they're very hard to draw. You know, all 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You get the point. It's hard to draw all 100 blocks. The only thing I want you to be aware of is when you see that block and it's split into the 100 pieces, you know that that is 100 out of 100 if it's completely shaded. And thinking about fractions and decimals, that's telling me that each one of those little cubes is a hundredth. each of the rod that makes up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was terrible. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8. I cannot draw that to save my life today. Let's try one more time. Much larger. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those rods that make up each column are a tenth. And when you are doing repeated addition, aka multiplication, when you are doing that repeated addition, I'm getting a little carried away now, aren't I? All you are doing is adding those together. So if you were doing 0.5 or 5/10 times 3, you would be adding 5 of those tenths together, which if you think about that, if there are 10 tenths in the cube, 4, 5, 6, 7, 8, 9, 10. Crude drawing. I'm not good at drawing today. I must be tired. It's Friday. I know you're watching this video on a Monday, but I'm doing it while you're all having fun right now. If you had three of these, you would have 1, 2, 3, 4, 5. You would have 3 of these blocks with 5 shaded in. You would have to start thinking about how I could put those blocks in there, right? If there's 5 and there's 10 total you can have, well, I have 5 from one, I have 5 in another, and I have 5 in another. Well, those 5 could fill up this whole one, so we would have one whole, and we would have 5/10 left over. It would really be 1 and 5/10. I'm debating whether or not I'm going to cut that out of this video because I just think that was a waste of time.